So okay, in this class we will introduce the concept of integral calculus. So to introduce the concept, we here consider a curve PQ and y versus x curve PQ, and we are interested, we want to find out the PABQ, this region, the area of this region. So we know that y is equals to f of x, and this point, at the particular point A, this is y equals to f of A, and at particular point B, this is y equals to f of B. So to find out the area, we have we divide the length AB by n capital N number of equal elements, and each of length n equal elements, each of length delta x is equals to b minus a by capital N. So delta x is the each length. So now the region is divided into some capital N number of rectangular bars. So to find out the area of the total region, we will find out the area of the particular rectangular bar, and then we sum up. So we can see that the area of this PABQ area, suppose this is I prime, is equals to, right, I prime is equals to then f of A into delta x, that is this rectangular bar, and then plus f of A plus delta x into delta x, that is the second rectangular bar, so plus f of A plus 2 delta x into delta x, so plus dot dot dot, how many rectangular bars are there? Capital N number. So f of A plus n minus 1 into delta x, the last one, into delta x. So this is the summation of the area, and it can be written as I prime is equals to summation I is equals to 1 to n f of xi to delta x. Now this area is not exactly equal to the area of the trapezium shaded shaped PABQ. Why? Because we are not considering these triangular areas. Okay, so these triangular areas is the difference between the actual area and this area. Now if we consider that n, we have divided the region into capital N number of elements, Now if we divide the region into infinite number of elements, then delta x turns out to be 0, because it will be more continuous if delta x, if capital N tends to infinite number of bars are there, so it will touch more the curve PQ. So the triangular area which are not considered in that mathematical equation, that will be tends to 0. So in mathematics this is called the integral of f of x. So we can say that this area I is equals to limit delta x tends to 0 summation I is equals to 1 to n f of xi into delta x and we can say the limit is taken as delta x tends to 0 as n tends to infinity, and the integration is written as I integration, this is the sign of integration, a to b, from a, this is x equal to a to x equal to b, and f of x dx. So this is the basic definition of integration, and this is called the integral of f of x with respect to x within the limits x equal to a to x equal to b, and a is the lower limit of integration and b is the upper limit. Okay, so let us use this method to find out let us elaborate this. Okay, so we are taking a graph again, y is equals to x graph. Y is equals to x graph. How it is looking? This graph will look like that. This is y equals to x graph. So in this graph we want to, okay, so in this graph we want to calculate the area of this trapezium shaped region. This trapezium shaped region is this is x equals to a, x equals to b, it is x, o, y, and this is p, this is q. Okay, this point is capital A, this is capital B. Okay, so how we calculate the area of this curve, area under this curve? Okay, so let us take the previous method, the basic definition of integration. So what we have done earlier, that we have divided it by some small rectangular bars, okay, and then sum up. So here we similarly we will divide it by n equal rectangular bars, and the each of length delta x is equals to b minus a by n. Okay, now the height of the first bar, this is x equal to a and also y equals to a, because this is x, y equals to x, too, y is equals to x. So this is height is equals to y is equals to x equals to a, and the height of the second bar, height of the second bar is y is equals to x is equals to a plus delta x, and this is a plus 2 delta x, a plus 3 delta x. So sum the height of the nth bar, the height of the nth bar is y is equals to x is equals to a plus n minus 1 into delta x. Okay, so the width of each bar is delta x. So the total area, now the total area will be I prime is equals to a into delta x, a into delta x plus a plus delta x into delta x plus a plus 2 delta x into delta x and plus dot 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 plus a plus n minus 1 into delta x into delta x. So this sum also can be written as I prime is equals to summation I is equals to 1 to n, just like before, xi into delta x. Okay, so where delta x value, the value of delta x is b minus a divided by n, and xi is equals to a plus delta x comma a plus 2 delta x dot 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 a plus n minus 1 delta x. Okay, so thus the required area if we delta x tends to 0 from the basic definition of integration, we can say that as delta x tends to 0, the total area of the bar becomes the continuous area. So that is I is equals to integration a to b x dx. Okay, I is equals to integration a to b x dx. Now the terms in the series was, if you my board is so small that I have to remove the previous series, so I write it again, that I prime was, we have write that a into delta x plus a plus delta x into delta x plus a plus 2 delta x into delta x plus dot dot plus a plus n minus 1 into delta x into delta x. So this was the area. So so you can see that this is a arithmetic progression series, AP series, and whose first term is this and last term is this. Okay, so and there are capital N number of terms, so the summation should be, we know that summation of AP series is n by 2 into a plus l, that is first term plus last term. So we will write it. Okay, I am removing this because of small area. Okay, so we can write I prime is equals to n by 2. So the first term is a plus n minus 1 into delta x. Okay, n minus 1 into delta x into delta x. Am I right or wrong? This is the first term, a into delta x, and this is the last term. Okay, I have write it. Very good. Okay, the next we will try to solve it. N into delta x by 2. Okay, delta x by 2, make it common, and this is twice a plus n into delta x minus delta x. Okay, now this is okay, n into delta x, n into delta x. Okay, we know that n is equals to okay, I am removing the curve to write it. N is equals to b minus a by, sorry, delta x was b minus a by n, so n into delta x is equals to b minus a. Okay, so n into delta x, we can write this as b minus a by 2, and this is 2a, and n into delta x like b minus a minus delta x. Okay, this is b minus a by 2 into a plus b minus delta x minus delta x minus delta x. So this is the area comes out from the summation. Now we can see that if delta x tends to 0, so I is equals to limit delta x tends to 0, so b minus a by 2 into b plus a plus b plus a minus delta x. So put delta x as 0, so this is b minus a into b plus a by 2, that is half b square minus a square. So this is the area comes out from the basic definition of integration. But we will not derive like that, this we will use the formula, and this is the basic definition. This is the basic definition. So integration a to b x dx is equals to this. Okay. Okay, we will study the next topic in the next class because it is going very longer.